Good evening, everyone, and good morning to others across the globe. Welcome to TDK Ventures' much awaited Energy Week online digital conference. We are discussing a variety of topics related to energy transformation, electrification, and beyond. This event is hosted by us at TDK Ventures, which is the corporate venture capital arm of the Japanese electronics giant TDK Corporation. My name is Anil Achyuta. I'm an investment director at TDK Ventures, and I lead our investments in energy and health tech. And so far, I'm an investor in 11 outstanding deep technology companies. I will be moderating our fireside chat session today with our esteemed guest, Mr. Bob Galyen. And please note, there are several events upcoming in Energy Week in the next 2 days. So please tune in and register according to your interest. I am delighted to introduce you today to our battery technology expert, Mr. Bob Galyen, who is a luminary in the industry. I am truly humbled by his presence here and looking forward to a stimulating conversation. Bob previously held esteemed positions at CATL, which, as many of you know, is the world's largest battery manufacturer, and served as their CTO. He was also the chairman of SAE International Battery Standards Steering Committee and CTO of NatBat International. These deep experiences provide Bob a unique leadership perspective in the global battery industry. Bob's mentorship and leadership in the entrepreneurial community is highly visible. And since we are entrepreneurs first at TDK Ventures, Bob is an automatic favorite for me. Bob, welcome to TDK Ventures Energy Week.
Thanks so much. I appreciate you inviting me to TDK Ventures Energy Week online digital conference. This is really a little departure from what I normally do. It's more like the battery show and big events like that. I get up on stage and dance around and talk to everyone. But what a great feeling of enthusiasm we're experiencing in the battery market today. But there's also some very big concerns out there about geopolitics, raw material availability, consumer adoption, amount of trained workforce, a host of other things that keep battery executives awake at night. And I'm quite honored that you've helped me out to participate tonight. And I've always had a soft spot in my heart for TDK since in my early days before I moved over to CATL, I worked for ATL, which was a part of TDK. So I certainly appreciate the opportunity, Anil. Thank you.
Perfect. Well, that's a perfect segue. Let's begin our session with a very simple start. I know you're former CTO of CATL, but we all love the story of David and Goliath in startups. Can you please give us a bit of color on how a very small startup like CATL could surpass the giants like LG, Samsung, Panasonic to become the world's number one EV cell maker?
Well, Neil, that's an interesting analogy, David and Goliath. I think it's more like David grew up to become Goliath. So, as a child, we didn't hear the story quite that way, but in this case, it's true. David became Goliath, and it was through brilliant strategic planning and execution to that plan that allowed CATL to rise above the rest in a very specific, accelerated rate. I think in many regards, CATL had a group of extremely experienced executives that worked in the consumer electronic battery industry for a better part of a decade before they moved into the CATL organization. And it was through that that gave them the knowledge to make extremely good battery products by making great decisions. And clearly, anyone in the battery business knows that scale means everything. Some people think, well, it was a piece of cake going from consumer electronic batteries to large battery format. No, it's not so simple. When you take a battery product to a gigawatt level production and expect to make it in parts per billion failure rates, that is not a simple task. That's an enormous task. And we did it in such a fast rate. It was just amazing. And I am so glad that you mentioned my involvement with SAE International, because in SAE International, we are working in 24 different committees, soon to add maybe 3 or 4 more committees to that plethora of topics that are inside SAE. But it's a really good testament to those people who are on the call tonight to see if they want to participate. They're more than welcome to send me an email. Let me know, and I'd be happy to help direct them to which of the committees would be best for them. And also in my role as CTO of NatBat International, which, as you know, is the world's largest professional trade association around battery technology. That is an amazing organization that Jim Greenberger has helped grow over the last 11 to 12 years. It now has over 250 companies in it. But let's get into the battery stuff now. So let's talk about lithium ion batteries.
Perfect. Okay, so there are so many new cell makers that are joining the game in China, EU, US, and beyond. How do you see the new landscape? What are the major essential ingredients of success that these new players can gain or even emulate from the biggest lessons at CATL?
Well, Anil, that's a great question. I just came back from the Hungarian Battery Conference in Europe. And during that time, everybody goes through the same growing pains. It's sort of like being a teenager in different countries, you know? We all have the same trials and tribulations. But the key elements of success in batteries isn't a lot different than other industries. The only difference is that batteries is an electrochemical device. It's like taking a bunch of chemicals and throwing it in a box, and suddenly magic happens that you create a bunch of chemicals and combine them through sophisticated processes. And then you put them into a box that stores electrons for useful work. We call them batteries, right? It's dispatchable energy. So the essential ingredients includes leadership, available raw materials, good labor, fantastic procedures. You got to have really good procedures to make a battery. Available raw materials, I've mentioned that so many times, and I will throughout the entire scope of this call. The productive equipment that you put in the plant that I mentioned a while ago, scaling from small scale cells to large scale format is a major undertaking. And excellent facility flow. That's another one that's key. You know, when I was a young guy at General Motors, figuring out how to make the materials flow through the plant use just smoothly is not easy to do. So there's a lot of other great technologies that we may get into later during the Q&A, but the list just goes on. There's a lot of reasons why batteries can be successful by using the same basic principles that we use in other businesses. The only difference is it's a chemical product. It's made to store electrons.
Maybe I'll double click in there. You did not mention capital.
Oh, I
Maybe
will. I will. Yeah, yeah, I will. Don't worry. That's your bailiwick, by the way. Go ahead.
come back to capital later, especially risk capital, right? It's hard to come by. I could be wrong here, but I see a potential for a country like India, for example. Do you believe India, with a demographic like China maybe 10 years ago, with the rising middle class, huge government tailwinds, can India be the superpower in cell making, especially with something like a better unit economics? What is your feeling here?
Well, I visited India back in 2016 and 2017, and I was quite amazed at the environment there. Was The air quality was not great. It wasn't any different than what I saw in Shanghai and Beijing, Tianjin, and all these major cities. Even back in the day in the 1970s and 80s when I worked in Los Angeles a lot, I never could imagine that yellow cloud hanging over Los Angeles, breaking through the barrier at about 200 to 300 feet, and then suddenly there's a ground down there. But these major cities and their air quality is a driving force behind electrification becoming a reality, particularly in a country like India. Therefore, my belief is that India will become a superpower within its own means to protect its citizens from an ever building air emissions problem from internal combustion engines, millions of them, the small scooters, two wheelers, three wheelers, and cars. The country's leadership recognizes that. And now that the industry is responding in kind, I think you're going to see some major things happening in India. In fact, I've spent a lot of time on the phone lately taking calls from people in India industry advising for the quality of improved player in their culture because right now it's predominantly internal combustion engine and we need to convert that over to electrification.
Great. But you do think that there's a strong talent in India to pull off something like a major superpower for cell making. What is your view here?
Well, India has a highly educated population. And what I found when I got to China working there is that a lot of the young engineers, a lot of students that moved into working in the factories, really well educated people. What they lacked was experience. And this is where the senior leadership of any corporation shines like a bright light in the darkness. That is, we have to help educate and train the young individuals that are very book learned people, but don't know how to apply those principles because most universities do not do a great job of teaching that. I found that in China and I found it in India and I still find it in the United States. We are constantly fighting how do we educate and train our workforce in order for them to come out of an educational program that can apply these principles in a hands on way. I always like to joke around when I hire people. I like to hire the old gray haired guys because they're already trained. They know what to do, they know how to do. You just plug them in and let them go. But the young guys, when you want to build a young workforce, you really do have to take them through that learning process and educate and train them. So I spent a disproportionate amount of my time when I was in China educating and training our people at the company. And you'll find that to be the case in India as well.
Very interesting. I think this will again come back to capital and availability of risk capital to companies that are developing a new entire ecosystem. I mean, think about Northvolt, right? How much money has it taken for Northvolt to get to where they are now? Do you think that there is a play from the government to really support these kind of initiatives? Of course, we cannot talk about batteries without talking about the IRA, the bill that was recently passed that was bipartisan. Do you think that other countries will also emulate
Mhm.
the United States?
Well, everybody keeps talking about they want to follow the European model, but the European model has not been proven yet. Okay. Not that it's a bad plan, not that it is an unacceptable approach. It's just that it's unproven. China has proven that their plan worked, not just with one battery company, but multiple battery companies. And today, this is one of the reasons China is leading the whole world in battery technology. And basically, everybody else is trying to play catch up now because China did such an effective job. So, this question is asking me quite often, Anil, what are the major factors that made China so successful? And I'll cover those very quickly. Number one was government support. The government in China did a wonderful job of putting incentives and tax provisions in place for the car companies and the battery companies and their supply base in order to make them thrive. The second main criteria was available capital. You ask me, capital was important because there's lots of guys in China that made money off of sugar and flour and steel and electronics and a whole bunch of other things. They wanted a little bit higher return on their investment, and they could see that they had great government support, and they saw that this is the new revolutionary wave in the world, not just China by itself. So they took money, invested it in the batteries, and they weren't wrong. The third key element was available technology. And as we mentioned before, the technology for consumer electronics was basically grown and built in China just because the whole world was sending all their orders to China to build the batteries that went into the toys, that went into the handheld computers, the tablets, as well as cell phones. So basically, the world handed the keys to the kingdom to China to build batteries in their culture. And then we all got the nice toys back in our hands all over the world. Well, China did a wonderful job taking that technology and applying it by scaling it up to put into electric vehicles. You know, their first target market was buses, and then it went into passenger car, and now it's propagating into a lot of other areas of the culture. But then the fourth key element is what I call the M&Ms. It's not those cute little chocolate things that I like to eat off my desk. It's the man and the machine. You have to train your people. And this is one of the biggest problems. I heard this all the way from Hungary to Canada to US to anywhere in the world, including Japan, Korea, and China. Everybody that gets into this business has to educate and train their people. We call it the man, or you could call it the people. We'll use the right acronym today, or you get chastised. And then the other is the machine. Taking a small machine from a small pouch cells and making consumer electronics is not easy to take it up to a gigawatt level. It's a whole new paradigm. You're going from small rolls to small consumer electronic type of products up to a large scale bus, car, or truck type of battery system. It's a completely different paradigm.
Wonderful. Well, we cannot talk about lithium batteries without speaking about supply chains. Just as a reference point to our listeners, the Tesla Model 3 has around 80 kilos of lithium. and people are speaking about supplying 1 million vehicles a year. So, how do you reconcile the entire supply chain of key raw materials challenge? And
Mhm.
what types of innovations are you seeing in the early part of the value chain in extraction and also on the recycling side? Because this seems like it's a problem that needs to be solved now.
Well, Neil, there's a lot of new technologies going on out there that could help address this problem. In fact, I just talked to the CEO of one of those companies today and asking him in preparation for this call if he'd mind if I'd say some comments about his company on air. But you think about the company called Impossible Mining, which is now called Impossible Metals. This is a company that is breeding a whole new technology for deep water accessibility to the rich nodules that lay on the ocean bed floor by the millions, if not billions. You're talking about a technology that this machine is about 16 feet tall. It goes down to the bottom of the ocean floor, and without stirring up the silt in any way, because it's put all the thrusters in the top of the robot for geostationary positioning, it uses an artificial intelligence camera system to look at the ocean bed floor. So it'll look at the nodules and say, oh, that's got a crab on it. I can't touch it. That's got an urchin on it. I can't touch it. It's got a seahorse on it. I can't touch it. But if it doesn't have any life form that's recognized with the artificial intelligence camera, it'll go down and pick up that nodule and put it in a basket. So these machines are doing this in a very environmentally responsible way of mining. Now, there are some companies that are mining that may not be quite as prolific at not damaging the ocean bed flora. But that's something for the normal business practices to accommodate for. If you think that mining the ocean bed floor is a bad thing by using dredging operations, then you shouldn't buy from them. But if you see that it is a potential opportunity for mining in a responsible way that's not stirring up the silt and creating problems on the ocean bed floor or damaging any of the aquaculture that's down there thousands of feet below, then try that. Another area is the new supply chain network that's being developed by new technologies. There's a whole host of new membranes that are being created that allow ionic flow to occur that can help separate and distinguish between ionic sizes by using proper nanometer pore control. So you can separate these ions in large quantities, not so different than desalinating ocean water to make good drinking water. So there's different technologies in that category. And then you look at the new technologies for making some of the active materials in a very responsible way by taking some of these raw materials and putting them into a superheated plasma like the company, it's not down the road from you, not far, called 6K. I love that company. It's amazing to watch what that group of people have done under Aaron Bennett's leadership. And they've created crystal structures like 811 single crystal NMC. That's an amazing feat of new technology. And they're able to make other active materials. So the challenge here is what's the next step? So I call it vertical integrated stacking. You take one technology that feeds into another, that feeds into another. So that vertical integration stacking is something that we practiced at CATL over the years. But for this particular venue, talking tonight, let's take that Impossible Mining Company where they take the nodules from the ocean bed floor. They use a different kind of degradation process to get the metals out, but degradation process could very well fit into the value stream for 6K that shoots it into the superheated plasma and creates these particles. Well, these particles could be used in another technology that prints electrodes by using a cool plasma technology that literally prints the electrode in a format that has very precise pore diameters and very precise conductivity networks built within the active material structure. The company that's doing that is a company called Intacells up in Michigan. Well, then there's a whole bunch of other cell companies that would love to have those electrodes that are made by this vertical stacking technology and put it into their cells to make electrodes that are superior to what we can make today. So I think that the future holds a lot of promise for us. Your question about the limited scarcity of materials, it will sort itself out. When there's money involved, mankind is very, very resourceful. They will figure out how to get access to those minerals and those materials that are needed to build these batteries.
That is an incredible piece of information. There's so much to unpack there. Maybe I'll double click on a few items here. You are right. There's so much exciting technology that are out there that will make better version of what we have today. However, it seems like we do have a fundamental issue on the promises that are being made from an OEM perspective, the volumes of vehicles that are being promised, and the speed at which the mines are going. It seems like they both are on a different time scale, and there's a little bit of a lag between the two. It almost seems like one is going faster than the other, and people need to somehow catch up. My favorite quote says, "It's easy to build a gigafactory, but it's very hard to build a mine." Or it takes a decade to build a mine, it takes 2 years to build a gigafactory. So, is there some other kinds of technologies that you've seen that will really make the raw materials access go faster?
Well, let me answer it in two different ways. The first one I want to go back and address as a part of the library group. We can't talk about all the things that we did because it was months and months of work. But the library group was chartered to come down to a set of suggestions that we would make to the U.S. House and Senate through the Department of Energy. It was a major piece of work with a lot of very smart people, and I really enjoyed working with all the folks. And it boils down to just the ability for mankind to innovate and come up with new approaches and technologies. But one of those is fairly simple, and that is how do we accelerate mining? Right now, the biggest problem is permitting. If you can imagine, permitting process slows down mining because it takes forever. In any event, I think the important point here is that these new technological approaches will help accelerate and expedite the generation of the supply of these materials needed to produce batteries. But we got to get past all the bureaucracy side of it. That is, getting the right permitting processes, getting through how companies can get through legislative policies and understand what the regulations are without violating them. Because the worst thing that can happen is you start up a new mine or something and you violate a principle of some kind that you weren't aware of, and it gets shut down to either a code of federal registry. So I think it's important to note that. The second element of answering your question, Neil, the new technologies. There's new materials that are coming out. There's new conversion technologies that are coming out. There's improved processes, and I've mentioned a few of those. There's better packaging philosophies that are coming out, as well as many other things that we haven't discussed. But I've got a few examples I'd like to share with you if you don't mind.
Please.
So these big oil companies were wondering, what are we going to do? What are we going to do with all this crude oil if we stop making fuel for cars, diesel, gasoline? Well, there is a company that I've been working with. It's called Lynova. It's a company that's using conductive polymer networks in the cathode that captures the ions. And these specific spatial orientated stoichiometric ratio polymeric chains can grab onto a ion that's in solution and kick out a free electron for useful work. Well, this is no different than using the lithium ion battery. It's just a different perturbation of the same technology, except this time you're using oil to make polymers that are used to make these super duper polymers with the functional groups that have the stereoisometric orientation so that you can just plug in that ion and kick out the useful electron for work. So there's a very strategic thought process there. Additionally, there's new technology around electrolytes. The same company's working on electrolyte systems that will not burn. Think about a lithium ion battery that will not combust. That's a pretty big deal. And that same technology or same company is working on new technology around membranes that will not short through because it's impervious to shorting. So these kind of innovations, Neil, I think are the revolution of the future. And when you stop and think about the thousands of people around the world that are working on battery technology today, somebody is going to make a major breakthrough someday. Because in the years of yesteryear, when we were working on lead acid batteries in the 1970s and 80s and even up into the 1990s for the EV1 that I was privileged to work on that program, they were also working on ancillary battery technologies called nickel zinc. They were also working on new nickel metal hydride batteries, which became the battery that went into the Toyota Prius series, and so on. So a lot of new technologies are bubbling up right now that has greater opportunities for success than what we had in the past. I can hardly wait for you to start asking me questions about some of the other sophisticated battery technologies that I might render my opinion on, but that's okay.
I think I definitely want to double click on one more thing you said: verticalization or vertical integration. I really love this terminology. And the reason is I feel that someone who has the full dynamic range of knowledge of extraction to recycling to different counts to membranes to dry printing or dry stacking to packaging to battery management systems, right? To software to pack design, etc. Someone should be putting these startups almost like a conglomerate. Who do you think it's going to be? Or do you see a battery manufacturer gutsy enough to take this kind of an approach?
Well, a lot of the OEMs are doing joint ventures with battery manufacturers out of a defensive posture so they make sure they don't get starved out of supply of batteries. And you can't blame the OEMs for that. And the other thing that it does, it helps protect the car companies, but by taking the name badge out of the picture, by creating an alliance between a car manufacturer and a battery manufacturer, now that new LLC has all the risk and the liability of a product that's being made by that company, not by the name badge car company or by the name badge battery company. It is a separate joint venture that uses intellectual property and technology from the battery company with a capital investment, typically coming from the car company. Now you've got two superpowers working collaboratively in making a battery technology, but you bring together the purchasing power of two companies now, not just one, because they can go out and buy a lot more materials and get a better leverage price point. So it drives the price of the product down so that the general consumer can afford the product. So there's a good strategy behind this. It's not rocket science. It's just a matter of philosophy of how you deal with other companies. So this is a good question, Neil.
Yeah,
We
I mean, I'm thinking of like a holdings company, right? The schematic that you shared seems like from the outside, it's a good template to create something for today, right? For today's NMC, it seems like this is a very nice template. However, the stuff that you described are really next generation stuff, right? So perhaps there's a holdings company out there that is trying to create this sort of a consortia of next generation battery stuff that can take this extra risk and really revolutionize.
Well, there's several different companies, and Neil, I thought I would hold this till a little bit later, but I'll make the comment now. I'm working on no less than about 8 different electrochemical systems. Each one of those different chemical systems has its strong points and its weak points. And let's start out with lead acid batteries. There's a small company that's near and dear to my heart, a good friend of mine up in Clare, Michigan, that makes lead acid batteries in a bipolar configuration. That battery works really well as an energy storage battery. It utilizes existing lead. It uses the same plastics and the same grid kind of materials that go into making a lead acid battery today. And instead of flushing the lead acid battery down the toilet, bring that battery back and use it for storing electrons to charge these high powered electric cars. You don't have to put lithium in all this energy storage network. Use lead acid. Charge your mobility products with your lead acid products, right? So one of the questions that I usually get is what's next in the lithium battery world, right? Well, then you have to look around the corner no farther than my old alma mater, CATL. They were working on sodium ion battery. So you just look at the plethora of new battery technologies that are coming out today. And I get asked the solid state battery question 1,000 times a week. I'm not kidding you. They're always asking about solid state. They exist today, no question. But at what price point can people afford? Now, for those people that are on the line, there's actually two different schools of thought around solid state battery. You've got the private equity guys that are out there working and beating the drums to get public money to come in. They have to make public announcements of what they're trying to do and what they're trying to accomplish. But then you got the really quiet big boys. You got the Samsungs, the SDIs, the CATLs, and Panasonics. You got all these guys that are self-funded internally. They're working on it too, but they don't have to make public announcement. They're not required to disclose. But those guys are out trying to raise new money. They have to in order for them to continue to raise money to propel their technology forward. So, out of all that, only three of the five golden rules that can't be met by the solid state battery today. And Neil, you've heard me mention the five golden rules, and I'll say it 1,000 times in some conference calls because people need to hear it. It's safety, performance, life, cost, and environmental. Now, we all know that solid state batteries are safer than liquid state batteries, but the performance sometimes wanes compared to where the liquid state is. In fact, most solid state batteries today are not true solid state. They're either partially liquid state, partially gelatinous state, and only part of the composition of the anode cathode separator electrolyte system is actually rigid, that you call a true solid state battery. Now, there are some true solid state batteries, but not ready for widespread gigawatt level production. So the three elements of the five golden rules that are usually are not met by the solid state batteries is the cost, the life, and the environmental side of it. I'd love to have the solid state battery companies come forward and tell me what kind of cycle life they're getting, what kind of cost they're going to have, and will it be valued at a point where the normal consumer can actually afford it, and what are you going to do at the end of its useful life? How do you crack into those rigid solid state technologies in order for you to recover those materials so that you can reuse them again and again and again, like lead acid battery? If you could trace a lead acid battery lead ion or atom around its circular economy, hell, some of those batteries from the 1910s and 1920s are back in service, probably 15 to 20 times in its lifetime. So I wanted to bring that up because this is a sticky point that a lot of people have about solid state battery. Will it happen? Eventually. I think we're very well on the way to getting a solid state battery sometime in the future, but I haven't seen it yet where it can be commercialized at a price point that everybody can afford and hit the cost, life, and the recycling characteristics or environmental characteristics that we'd love to see happen.
Absolutely. That brings me to the next question is your view on the new chemistries, meaning the aluminum battery, the magnesium, the potassium ion, even beyond sodium. It seems like there's a lot of nature papers that are written in the academic circles. And unfortunately, the cycle time for developing these things seem to take about 10 to 20 years, regardless of what you do. Is there something that you see that's being compressed? Are the right minds, are they coalescing together to make it faster? Because it seems like a potassium ion or a sodium ion would be much more easier in terms of raw materials availability, cheaper, and so on. Although
In 1975, I can remember in my physics and chemistry classes, I was using a slide rule for doing all my logarithm and power function type of calculations. Doing eigenfunctions on a slide rule is a pain in the backside. But then the next year, I went out. My mom and dad helped me buy a very expensive calculator for $850 that did nothing but square roots, logarithms, addition, subtraction, multiplication, all the normal, STEM mathematics at a grade school level. Okay, and I was in college. Well, fast forward to 1983, I started working with Dr. Hiram Gu at the GM Tech Center. We started working with this magical thing called Symphony, which was an early version of the Excel spreadsheet. We were doing stick models to do calculations for the height of the windows that we put in our lead acid battery grid and the width of our tabs. And guess what? We were saving $20 million a year in lead by that simple little stick model. Now, fast forward from 1983 timeframe to 2013 at my job at CATL, we're now working with sophisticated mathematical models, the same kind of models that some drug company would use for calculating the right chemicals that go into making a new pharmaceutical drug are the same kind of mathematical models that you can use from molecular orbital theory to calculate what are the right interstitial spaces for creating the storage lattices for these ions to plug themselves into to kick out that free electron for useful work. Well, I always like to joke around from that time forward that we used to do mathematical modeling from the angstrom level to the meter level. That covered everything from the chemistry that goes into the molecules all the way to the crash worthiness of that vehicle with the battery pack in the belly of the beast. So when it crashes, you can actually calculate how much force that battery pack can take and whether or not it's going to run into a problem or not. So the mathematical modeling has been enabled by the advent of computers and the rate at which artificial intelligence is being triggered into our society today. It's going to be an astronomical event sometime within the next decade of how fast we will be able to computer model all the things that go into every aspect of what we're doing. We're extraordinarily close today. But you ask about how you can speed up technology, you can mathematically model almost anything if you know what you're doing.
Wow, that is really, really inspiring. And I would love to see more entrepreneurs inculcate this into their development to shorten the life cycle. I'll ask one last question and then open it up for audience questions here for the last 15 minutes. As you see the current situation, post pandemic supply chain crisis, risky sort of economic environment, perhaps some inflationary environment, what are your suggestions for battery technology innovators and entrepreneurs, especially in this capital constrained environment?
Being in the battery world is not for the faint of heart. I've said this to many people, Anil. Being a battery scientist or being a battery engineer and getting into battery manufacturing, it is a tough, tough business because you're working with a bunch of noxious chemicals that you, as a scientist or an engineer, are required to take those noxious chemicals, put them in a box, make them perfectly safe, seal them up, put them in a car, and expect to be able to crash it into a tree and the result be good. It's a very tough thing. But
Buckle up.
uh, if you really believe in what you're doing, you should pursue it, right?
Absolutely. So I'd like to start with some of the Q&A here from the audience. First question comes from Catherine He, one of my colleagues. The question is, most US startups making lab scale pouch cells and claiming they can achieve a very large energy density rate performance. How much do you trust these data they showed, and how far do you see the battery startups in US go?
Well, the best way to answer that is you need to see what the performance is going to be over a long period of time, how it's going to be packaged. You can cycle a lot of good pouch cells in a laboratory under optimum conditions, but when you start assembling them into either a module or putting them into a pack, at the right compression with all the different temperature perturbations and user profiles of extreme cycling. Some people are going to drive a car into the ground before they charge it up. Others will probably recharge it too much. There's so many different perturbations, events that are going to occur in real life usage. There was some data that I remember very distinctly from the guys from Toyota and Honda back in about the 2015 timeframe. I remember the presentation was in Beijing. They were so surprised that people with electric cars in China were plugging in their cars 1.6 to 1.7 times as often as they expected them to, which was pretty amazing. That means that those batteries were staying charged all the time. So some of the damage in batteries can be done overcharging. Some of the damage is done by putting them into too deep a depth of discharge. So the big question is, where's the sweet spot? The guys at Tesla have figured out, well, we're going to clip the recharge up to about 90% or 95% of the rated capacity by an adjustment that you have in your window on your car. You can set it so that if you're going to take a long trip, you can take it all the way to 100%, but they recommend you put it at 90 to 95% so that you don't overcharge your battery too often. Good strategy. That battery will last them a lot longer in that case. So for those people that think that just because you have great results in the laboratory with a pouch cell doesn't mean you're going to have great success in the field until you actually take it through its rigors of how the battery is going to be used in the application.
So then maybe the question is we should ask those startups to come back with a bigger cell, maybe 2 amp hour, something like that. I'm trying to find a happy medium because, again, as a capital allocator, it would be difficult to expect a little startup to come with a final car data.
Well, you hope that they have enough capital to build a bigger cell that will demonstrate that at a larger scaled up cell, they can get the attention of another capitalist that will help put the money into their program so that they can build more batteries and prove their point. Because if their technology is that good, Again, it's about the passion. Do you have enough passion to carry it forward? And most guys figure it out one way or another.
Perfect. Let's go to the next question. It's from John Liu. Hi, Bob. What's your take on charge speed of lithium battery for EVs and battery safety?
Well, it depends on which technology you're talking about. There are some battery technologies out there that can take extremely high fast charging. Some, 3C rate, 5C rate. Let's pick on the guys down in Australia. The guys in Australia have a graphene aluminum battery that you can charge at 70C rate. Okay. So it depends who's asking the question. It depends on the chemistry that's involved. It depends on the thermal management system you have around the battery system. It also depends heavily on what kind of signal what kind of charging system you've got that can hit those kind of high power charge levels at the pack level. Because today, one of the biggest problems that we have in the infrastructure is being able to fast charge cars in the field because there's not enough high power chargers out there. It almost defies logic to go out and find a level 3 charger anywhere in the general community. It's hard to find them.
Very, very true. Thank you very much. Next question comes from Jonathan Malfabon. Bob, what does the future of lithium mining look like? Will we have more significant mining in North America? Good question.
Well, it depends on where in North America you are. If you're up north, you're probably going to buy a lot more lithium than you are in North America because, as best I can tell, U.S. Geological Services have found there is some lithium in the United States, and it's predominantly in the brine form. There's a huge pond of brine underground. It stretches from Arkansas all the way down into Louisiana if you want to go get it. It's difficult to find. You got to dig a little bit to get down there, but when you do, there's a lot of it down there. Now, of course, everybody talks about the Salton Sea and some of the other places out in the west part of the United States, but lithium itself is not necessarily in the plentiful amount that we would love for it to be in here in the United States. So we have to rely on our folks up north. And there is some down in Mexico if you want to go look for it.
All right. Well, that sounds very exciting for all the explorers out there. From Sergio Barron, Bob, will computer design and computer controlled additive manufacturing be important in the battery industry? Very cool.
Absolutely. Let me explain why. There are companies today that use additive manufacturing, and there's actually some talk of actually building the entire battery by printing it, by using a combination of additive metal printing and utilizing cool plasma printing technologies. It's not just one technology, it's a combination of technologies that can come together to literally print the entire battery. Now, this could be a strategy for future solid state batteries, depending upon the architecture of the science that goes behind those batteries. But conceivably, Neil, it can happen. So, Jonathan, that's a good question. I really appreciate you asking it because it is possible.
Very, very cool. Next question comes from Amol. There are some claims experiments from Jeff Don et al. For 100-year battery. Thoughts?
Jeff is one of my most admired people in the industry. I love Jeff. He's a smart guy. Jeff may have something up his sleeve that the rest of us haven't discovered yet. And I admire Jeff for making those kind of comments because he might actually have it. The question is, what's he going to do with it?
Do we even need it? I don't know. A question from Derek Meng. With the trend towards much larger cell formats, do you believe existing vendors have demonstrated sufficient safe pack vehicle design? Good question.
Well, let's put it this way. Depending upon what the technology is, we talked about this fire resistant battery earlier. If you've got a fire resistant battery, you can put it in a lot of places in the car that you can't put it today. Most car architectures are built around the philosophy of putting the battery modules between the frame rails of the vehicle for the fundamental reason it's outside the crush zone. Okay. You don't want to put things in the crush zone if you don't have to. But in the cars of the future, if a battery technology is safe enough that it cannot combust, it's fair game where you put the batteries. We just have to train the first and second responders that when they come upon a serious car accident where some of these dismembered battery systems become live or active, with which basically goes around the safety system of the battery pack integrity, then the first and second responders would need to be trained to handle those kind of situations. But I see absolutely no reason why in the future battery pack systems, particularly if they're solid state battery and have the safety factors that we've been talking about, cannot be put in places like the rear trunk or the front hood line or somewhere else, because part of the drive range in the vehicle is dependent upon the height of the battery pack that we have today, which changes the CDA bar on the car, which is the aerodynamic drag coefficient. If we can cut down on the aerodynamic drag coefficient by shortening the hood line or shortening the total height of the vehicle, it goes a lot farther. And it's a pretty good contribution when you start looking at long drives.
Very, very cool answer. Thank you for that. And last question here comes from our colleague Alex Zero from Group One. Hi, Bob. Is there an overinvestment in battery manufacturing and underinvestment in battery materials? Traditionally, battery materials has not been a popular sector for investment in the venture community.
Well, I don't think that we can build enough battery plants fast enough to hit all the targets worldwide. I believe that there's some fundamental numbers floating around that say we're probably going to have a 40% shortfall by the year 2030 because the rate at which electrification is being adopted by so many different aspects of our society. It's not just cars, it's not just buses, it's not just trucks. The last thing I did before I retired to come home from China was I drove a 22-ton backhoe by Liu Gong in China. This thing ran off batteries for 8 hours digging dirt, and a 22-ton backhoe is a big machine. So electrification doesn't just stop in cars, buses, and trucks. We are now looking at electrified aircraft. I did a study on this 3 years ago. There was 101 companies around the world that were startups to make small aircraft in the 6 to 12 passenger complement and utilizing regional airports because regional airports are less than 5% utilized. So we also are now seeing a plethora of electric trains bubbling up that will have a large battery pack array on them along with a fuel cell for charging them. So we may see something in the future where some of the big diesel locomotives may be replaced by fuel cell battery driven technologies that allow the battery pack to utilize its plentiful electron source to launch the train, and then the fuel cell, while it's out doing its normal run, is charging the battery pack and fueling the drivetrain for the locomotive. So in marine applications, lots of big ships today are using battery packs, particularly for their side thrusters and for their coming into port, because many countries around the world are outlawing diesel engines about 5 miles, in some cases 10 miles out from the ocean, instead of paying for a very expensive tug to come out and retrieve them and bring them in that is electrified. They use their own propulsion system to get them into port. And these are typically electrified. And there's some electrified marine type applications in Europe that's fully electrified and they're autonomous. So there's lots and lots of applications going forward. So I'm not worried about overproduction of batteries. I'm worried about underproduction of batteries.
Well, thank you very much, Bob. We have one last question, almost like a rapid fire, okay? Just with one or two words. This comes from Prasanna Nambi. Beyond China, currently dominating battery manufacturing and innovation, for long, who else will take over if anyone ever will?
Neil, that's a loaded question. Let me explain why. You will not beat China on volume. China has won the race in the number of people in their country. They are the number one nation in the world as far as population. They have 5 times as many people of those people in the United States. The best way to beat China is make it cheaper, better, and faster, if you can. The only way you beat China is cheaper, better, and faster. Do not try to beat them on volume because you will lose.
Well, thank you very much, Bob. This was really, really fascinating. A conversation with Bob Galyen. To all of you. For all of you who joined us during this session, sincere thanks for taking the time to participate. We at TDK Ventures are always sharing our learnings openly. You're welcome to view these videos that are available to public. You will have to just log into the AirMeet platform and you will be able to see it for free. If you'd like to watch this session online, in case you missed it, no problem. We have it covered. And for all of you who will be joining the next session, welcome. we have so many more amazing fireside chats, panel discussions, and such. So we welcome you to participate and give back to the entrepreneurial community. Thank you again, Bob, for your participation in Energy Week. We will see you soon, and sincere thanks for you.
Thank you for the opportunity, Neil.